Those of you really paying attention will know that this is not my home, and also this one is going to be much more chatty, a bit like the one a couple of episodes ago, rather than me just doing voiceover, which was pretty much the last episode when I was talking about the competitors to the potential Bernard vehicle, where I was looking through all the other historical and more up-to-date vehicles which work in the Arctic. So this is going to be the one which is probably going to be causing a storm of comments, because instead of me just talking about my wants and needs and general abstract aim for the project, on this one I'm actually going to be telling you what at this stage I think the Bernard class of amphibious Arctic vehicle is actually going to look like, the basic systems that I think are currently going to be the best options. Nothing is set in stone. Things will change along the way. I may well decide early on, or even after something's been manufactured and tested, that I need to change. But this is what I'm going to be working on at the moment. And I've listed down here, so I don't sort of miss out any big obvious ones, the main categories which I want to share with you today. And so I guess I'll start from the top. The first one is going to be the hull shape. And we're talking about a hull, and you're thinking, oh, isn't this supposed to be like a tracked land vehicle that might go in the water, or is this a boat? What is this? It's not really going to be a boat or a car or a truck or anything like that. It is simply going to be a Bernard, and Bernard is going to have a hull. It's going to have a monohull, so let's call it or if you're sort of thinking in car terminology, you call it a monocoque, which doesn't have a separate chassis and body. I want the hull to be boat-like in a lot of ways, almost sledge-shaped, which are two pretty similar designs if you really think about it. And I want it to be not twin-hulled in the sense that you've got one hull, and they're sort of joined across the top by a platform. I want it to simply be one large semi-planing hull so that we can travel faster than the hull speed. But it's going to have two shallow keels, which will be good for stability, but also good for mounting wheels, tracks. I won't spoil the decision about wheels or tracks until we actually get down to it on the list. But anyway, I think that having a hull shape, and by the way, I was been playing around with AI quite a bit recently to try and get some very basic representations of what Bernard might look like. And it turns out that the ones that generate images they're a bit average at the moment, and they just won't do what they're told. They keep on giving me 8 wheels when I want 6 and all sorts of different stuff like that. But actually, I had a bit of a play. There was one option that looked a bit like this, and another one that looked like that. And then there was that original one, which I got made into a sticker, which looked like this. And that was never going to be it. But I thought it would be a good idea to see whether those image generation AI bits of software, we're talking Google Gemini, ChatGPT's image generator, all that sort of stuff, whether they could do sort of almost like technical sketches. The answer is not yet, or at least not with the instructions I was giving them. Whatever I was trying to tell them, it got the little people inside the AI machine very, very confused. Anyway, so we're not doing that. But coming back to the hull shape, I'm going to have to just describe to you what it's going to look like in words, because I can't give you imagery for that yet for that very reason, and I haven't done the technical drawings yet. Anyway, the hull shape is going to be sort of like a single entity, but with two shallow keels, which are going to be areas where you can mount the propulsion systems on, and a large internal single cabin where we're going to make the very, very best use of space. Right. Vehicle configuration. There's not going to be one hull. There are going to be, per vehicle setup, 2, and I want the vehicles to work in groups, maybe 2, maybe even 3 sets of vehicles, so that if there are breakdowns or emergencies or problems, they can help each other. But if you look at just the one unit, and I guess this is borrowing an idea a little bit from the Huglands, so or the Vikings, or whatever you want to call them, the BB-206s. The idea of having an articulated twin hull system, so you've got one in front and one behind, connected by something. Will it be a solid coupling? Will it be a not an elasticated, but like a softer coupling? We'll discuss that at a later date. But my idea is that we're going to be separating the two. And that's because I want to have the noisy bit, and this is a bit of a cheat about what's going to be powering this whole caboodle. The noisy stuff I want to be in the area where the human beings are not spending all their time. So I want the rear one to be the power plant and the front one to be the command module where the crew live and do all of their stuff. So I want to have 2 of these holes, and I want the holes to be identical so that actually you could, if you really, really needed to, either share parts between the 2 or even abandon one half and move off with just the other after a bit of a fashion and a bit of hard work. So 2 holes, same shape, same everything, maybe with a different roof, because the one roof will need to be just super insulated for the rear section. The one in front obviously needs to be with windows with lots and lots of flexibility, and maybe a place where people can stand or even go even higher up to get visibility up on the roof. Anyway, so the bottom of the holes will be identical. It's what's going to be going on top that will vary a great deal. Right, so that's the vehicle configuration. Size. We're going to be constrained by the size of a normal shipping container. And I've already said that I want the vehicles to be able to fit in the shipping container. And also possibly, with all of the gubbins taken off, they could even nestle in each other. Not quite like Russian dolls, they'd all be the same size. But you could possibly get 2 or maybe even 3 of them sat on top of each other inside a single container. And that could make shipping these things around the world much, much, much easier. So we're looking at about 5 meters long per hull and a fraction over 2 meters wide. So it's a pretty significant size cabin and plenty of space to get all sorts of things mounted, ready, plenty of crew, all of their food and all their equipment, maybe scientific equipment, all sorts of things, so that the vehicles are versatile and they can do all sorts of different tasks, maybe not just for me and my projects in the future, but for other people. Next one, the power system. This is a big one. Are we going to have one huge diesel engine? Are we going to have a modular nuclear reactor? Are we going all electric and pretending that a load of wind generators on the roof are going to power us along, like some people always thought that I could power Alan with a couple of solar panels and a wind generator? Anyway, those of you, by the way, who are just looking at Project Bernard, who don't know what Alan is, look at the rest of the channel. It kind of dominates. By the way, Alan's doing very well. I've had a number of really nice people actually interested in taking on Alan. So hopefully I'll have some positive news on Alan soon. But next one, I'm talking about that power system. How is Bernard, or sort of the 2 Bernards, how are they going to be moved along? We are going to go, and this won't be a massive surprise, we're going to go diesel electric. And so we're going to have the actual power being delivered by electric motors, but the energy generated will then be stored in batteries, and then that can be distributed to the motors and then power all of the other electrical systems on board. Diesel generators. And there won't just be one, because we're doing super redundancy, of course. If one thing breaks, you don't want to be completely stymied. You want to be able to have the ability to lose 1, 2, 3, maybe 4. The idea that I've come up with, and I've done some rough estimates on power requirements, I think that having 4 quite modestly sized identical generators all in a row will be perfect, because we should be able to work with 3, so the 4th is almost a redundant one, but will give us a little bit of extra breathing space. But that would mean, of course, that all these spares can be shared, and they won't be individually that heavy, just in case one of them needs to be lifted and moved and so on. We don't want to have 200 or 300 kilogram generators, which obviously can't be moved around by 2 or 3 people. That'll be a nightmare. So it'll be slightly man portable, trying to if we need to move one from one vehicle to another, or take it out into a separate vehicle or into a tent or something for maintenance. Who knows? I want to have that versatility built in, and so obviously the power will have to be transferred across the articulation from the rear power unit all the way to the command module, to the command Bernard, and then powering our wheels or tracks. Still not quite at that item on the list yet. Now, I've had a long chat with people who really do understand large industrial diesel engines, and particularly how to get the best possible fuel consumption out of them at sea, in large ships, in smaller vessels, and so on. And I was tempted to try and go for a straightforward diesel or diesel alternative solution, because if you can get everything perfect, for instance, there are ship engines which are designed specifically for a ship to, without even needing a gearbox, to turn the propeller, which is again obviously perfectly designed for this whole setup, to turn at native RPM essentially. So the sweet spot for fuel consumption for the engine is exactly the number of rotations a minute that the ship needs to cruise for weeks and weeks and weeks at sea. We are not going to be able to have that opportunity, and I've been looking at the options that have been chosen for the Burlak and for Yemla, which is just use normal big truck engines. I think Toyota engines, at least for one of them, and have a normal truck layout. The problem with that, and I was thinking about fuel consumption, is that when you're stopped and just having a look, choosing where to go, having a chat amongst the team, you're idling, you're burning fuel. What I like about the idea here is in absence of the opportunity to have one large engine turning at native RPM at a constant speed the whole time, which you're never going to be able to have with a vehicle like this, so putting that ship idea out of my head entirely, what I liked is the idea of always being able to run the diesel engines, and in this case it's going to be a load of generators, to run them at their optimum load, which for diesels is normally a high load. And then all of that energy, obviously there'll be inefficiencies through the system from conversion, moving DC to AC and back again, and obviously burning fuel is not necessarily the most efficient thing in the world. But then all of that energy is going to be stored in the batteries, but then only deployed to the motors when they are being used. So if we do stop for a minute and we're looking around the vehicle to try and work out whether we're going left or right, the diesel generators are going to be running in the back, charging up our batteries, but we're not going to be wasting that fuel. Whereas if we were running a diesel and didn't want to keep on turning the diesel engine off, you are going to be idling a lot and just burning fuel to no effect whatsoever. Nothing's getting charged up, it's just genuinely wasted. So I like this idea. So let's put the idea of one single, quite fallible diesel engine per vehicle out of our heads. I think the redundancy given by having multiple generators is great, and we're going to be wasting less fuel when we're not actually turning a motor and actually going somewhere. I think we're probably going to be looking for either 4 or 6 driven motors. That will be subject to change when I look at the pressure that the items that we're going to be sat on will apply onto the snow, and also what sort of torque we're going to be able to generate so that we can get up over large bits of ice and climb up out of the water onto the ice and so on. So there's all sorts of calculations which need to go into that. So we are TBC when it comes to the number of motors that will be used. It certainly won't just be 2, because having a 2-wheel drive vehicle sounds rather daft to me. Now, I said diesel electric. I was slightly lying. We're not going to be using normal diesel, because I've come across this slightly more expensive, but as far as I can tell, better in every way, type of fuel which all diesel engines can run from, and I also gather with no real modifications. I'm going to be looking at HVO, which is essentially like a green biodiesel-ish, but it's created from vegetable oils which have gone through an industrial process to change them, and so that they simply run as diesel would in a diesel engine, generator and so on. That is pretty clever, and I've been looking at the numbers, and there's a fair amount of documentation and reports and everything online, because this is not a brand new idea. People have been using HVO for quite a while. It appears to have the same energy density, which will be important for how much we can store and how many miles we can get per gallon of it. It appears to have really good low temperature characteristics, which is great, and I think you can get away with using fewer additives in order for it to start cold. That's excellent news too. Another big environmental one, if there are spills, I'm not sure if it's exactly like simply providing fish food, but it doesn't have anywhere near the environmental consequences of, say, having a large fossil fuel diesel spill would. And so it's basically, apart from the money thing, it is more expensive than normal diesel. It sounds great. So we're going to be doing a lot of investigation into HVO for our fuel source. Okay, I now need to talk about tracks versus wheels. Tracks are great for all sorts of things, but they are very complex. There are endless things I've seen on TV shows, YouTube channels, and proper reports about how tracks do often need vast amounts of maintenance. They fall off, they get gunked up. Tracks are incredibly effective at getting traction on, like a snow surface. Of course they are. But there are lots of buts. And there's a reason why a lot of these modern vehicles that I shared with you in the competitors episode have been going instead for large, low pressure wheels. We are going to be going for large, low pressure wheels. But I'm interested in not having ones that inflate. And I know that the ones that are currently not on the market as such, but are being developed and used by the Sherp, by the Himalaya ones, all those sorts of large, big balloon tires, they do contain either gases. I think some of them use exhaust gases to inflate and deflate them, and some just use air in a normal compressor. But of course, they run the risk of course, being punctured. I don't think they have a bad habit of doing so, but obviously there is a chance. I'm going to be looking instead to airless tyres. There are a load of patents out there for the moment for those, so we have to be a little bit careful. I know that Michelin have come out with their type of normal car tyre, but they also make them for lawn mowers, I think small tractors, all sorts of things like that. So these are wheels which obviously can absorb shock and lumps and bumps as you travel over a certain surface. But the key thing is they don't have any air in them, which is kind of the holy grail, I think. If we can get the technology right and if we can come up with one that is large enough to work on Bernard, I think having 6, maybe 8 large, very low pressure, but adjustable depending on the sort of terrain that we're on, airless tyres, that's what we're going to be working for. Right, what's the next one? I've put top shell style down here, and what I mean is the roof of both of the different types of vehicle, and the shells are going to be made from composites. That's the reason why I've been doing all of those carbon fibre dial-in tests recently. We're not going to be going for steel or aluminium, and there's no reason why we shouldn't be going for that same high performance, low weight option for the roofs. I want to have lots and lots of visibility from the command Bernard, and that means that we'll want to have large windows, maybe even on the roof. I don't know how many panes we'll have, whether there'll be lots of small panes. I do want all the panes to be exactly the same size so that they can all be interchanged. That'd be a good idea. I don't know whether we're going to be going for acrylic or polycarbonate, because there are pros and cons with scratches and thermal characteristics, and obviously shatterability, all sorts of stuff like that, how much they need to flex, how thick they'll be, whether we go 1 pane or 2 panes. But anyway, there will be plenty of visibility in all directions out of the command one. Maybe either none or very few, maybe an inspection window on the rear one, but I think insulation will be the key there, and obviously the ventilation system will be different for the rear vehicle than it will be for the front one. Obviously, on top of the top shell, there'll also be things like antennas, there'll be lights. I want to have a telescopic extension that can go really, really high with the camera on, so that we can search ahead for routes or obstacles or leads or so on. And so that will probably be on the front one, but rather than the rear one, so there'll be lots of space to mount stuff. Also around the shell, we'll need to mount a winch, both fore and aft, and there'll obviously be a huge light bar at the front as well, so we can light things during the darker months of the year. So that's what the top shells are going to very roughly look like. I don't know whether they're going to be curved and rounded or more slab-sided. I think for ease of manufacturing, slab-sided is easier, but of course that can have an effect on its ability to bend and take impacts and so on. Also, do we or don't we build in a roll cage or a roll bar? Do we simply work hard at not rolling the vehicles over, or do we design in extra safety, which will obviously weigh more, in order to save the lives of those inside if we do roll onto our back? So we'll have to have a discussion about that. The internal layout of the command Bernard will obviously need to do all sorts of different things. You'll need to have people seated safely and comfortably for driving and for observations, also for our living routine, eating, sleeping and so on. We'll have to make lots and lots of different uses of lots and lots of different things. That's no new thing to our channel. There'll be a working area for things that need to be repaired, maybe people doing science prep work, all sorts of areas. And so there'll be an area which can be used for sort of working with lots of good quality light. And then there'll be a domestic area, maybe even I wouldn't say a shower, but there will be an area where people can wash, do the obvious, and have a good time of it, because this isn't going to be a vehicle that you're going to be in just for a few hours. People may need to be operating from these vehicles for weeks and weeks on end. And because we're doing now a ground up build, I have the choice of making things really good from the off and not having to shoehorn my ideas into a vehicle that already kind of exists. And that was always a drawback with the Alan project. So we have the opportunity now at the design stage to get all of that absolutely right. There's going to be a night routine. Of course, we're going to be sleeping in that front vehicle. And so, for example, the seating for during the day might then be collapsible into really comfortable beds. So trying to make use of everything, so that whether you're working day or night, everything kind of has a purpose. And for the power plant, one of the two shells, obviously it's going to have its roof, and so the internal area will be laid out differently. There are going to be 4, not enormous, but there will be 4 generators inside there. There will need to be a ventilation system. There will need to be a heat reclamation system. Mention that in a second. And there needs to be storage for food, obviously for lots and lots of HVOs, lots of our fuel, and also for any kind of other payload that we're taking with us somewhere, whether it could be a fuel storage system that's going to be left somewhere on the ice for use later on or so on. So that have to be like a multi-purpose storage area at the back. But there'll be plenty of space. That's just over 2 by 5 meters long. So that's a good 10 square meters of space. That's pretty good for storage, and we can build that up reasonably high. On top of that shell, I'm also interested in putting, probably not solar, because the amount of sun you get there, because of the way obviously the Arctic and Antarctic works, solar isn't particularly effective for most of the year. It would be nice to have some wind turbines there though, because although we'll have plenty of opportunity to use those generators to charge up our batteries, which by the way I'm really hoping will be sodium ion batteries, and I've got a test on that coming for you soon. I've been doing all sorts of head-to-head testing with different types of batteries. It would be nice to get some free energy, of course, and the Arctic does have a tendency to be quite windy, and so we might as well use that if I can find lightweight, reliable turbines that can be mounted on that rear one of those two shells. Heating. We don't want to waste fuel, so it would be daft not to use the heat that's already being generated by the generators, and of course they're going to be producing exhaust gases probably 500-600 degrees centigrade, if not more. Let's try and use that, and that's not going to be generated inside the command module, inside the command Bernard. And so we need to move that heat without pumping exhaust gases into where people are going to be sitting. We need to intelligently move that heat from one place to the other. And so I'm currently investigating all sorts of different HVAC technologies, new solutions that are being invented all the time. And there are quite a few dry air-to-air heat exchangers available. I want to avoid a wet cooling circuit if I possibly can, because although of course fluids are more efficient at transferring heat, they can break, they can fracture, you can get floods, all sorts of different dramas like that, and it would be really good, even if it's less efficient, I think, to have an air-to-air heat exchanger which can then be pumped actively into our living area to heat that up. There will need to be the ability to cook, again, not using electric, because cooking with electric is super energy inefficient when it comes to having to store the power and then using it again, so we might as well just burn HVO for that too. There will be a diesel stove of sorts inside the main living area, which you'd only normally use when you're cooking, but it could be used as an emergency heating source if for some reason we're not getting heat from the power plant Bernard. Right, water. Normally the source of water will be snow, collecting snow, melting it, using it for fresh water, for drinking, washing and so on. But also there's going to be an issue with condensation. Of course there is going to be, no matter how well you design the windows or the shell with foam insulation in the core of it, you're going to get condensation. Let's use the condensation. And so I'm going to be coming up with a system of dehumidifiers, probably both desiccant and condenser for different types of for different temperatures, because they work at different effectivenesses depending on what sort of temperature is ambient. And that will then be able to reclaim the condensation, which will be annoying us and getting all over the acrylic or the polycarbonate or inside the shells or whatever, and turn it into usable fresh water. So that will be a win-win. Obviously it will use some energy, but we'll have to try and make that as efficient as possible. So yes, dehumidifiers will be our friend. Stowage. I've kind of mentioned that I'm going to be apportioning a large area of the power plant Bernard for racking for fuel and food and so on, but also for personal equipment. There will need to be some clever use of the inside space of the other of the command Bernard as well. That's going to be things like under seats, using every single bit of space, keeping it low down for good weight distribution. We'll try and cleverly build storage into all the little nooks, crannies and areas that otherwise wouldn't have a purpose. So that's just going to be down to a little bit of good interior design. I never thought when I was planning my career years ago I would be the interior designer of something called Bernard, but life's a strange thing. The next one is water travel method. Now you've seen how Sherps and some other vehicles have sort of paddled wheels that can make some kind of progress when they're actually on normal liquid water and not on the ice. That's all very well for a few meters, and they're obviously not very fast, it's difficult to control, it's going to be very power intensive. Right, that's all well and good, but I think we can do an awful lot better, particularly if sometimes we have to travel not long distances offshore, learn that lesson. But if doing maybe a couple of miles down a lead, those of you who are not sort of Arctic people will not know that a lead is basically the bit of water between pans of ice. So it's basically where the ice cracks and you have water in between that hasn't frozen up again. That's called a lead. And so what if you want to make use of that? Get in the water and off you go. And so I want some other way, rather than just trying to paddle our way along using wheels, a really good way of moving efficiently down there. So what I'd like to do, using the same power source, which is going to be sodium ion batteries at 48 volts, it would be good if we can just have an electric motor, a pair of electric motors, which it won't be very fast, it'll be a few knots, but they'll then be able to be mounted on the rear of either one or both of the modules and will just power us along. Much, much better than just trying to use the wheels. Whether the wheels can be retracted, taken off, I don't know, or just sit there and, yes, provide a little bit of water resistance, but sort of sit there and do nothing as we're moving along, that's yet to be decided. The next one is weight aims. How much is this going to weigh? And we were talking about some of those other vehicles in the competitors episode being, well, some of them like 35, 40 tons. Obviously, we're not in that category. Some of the smaller vehicles are still 3, 4, 5 tons. It's the Yamala, which I think is just over 2 tons, but that's a more conventional truck layout. I think that we will be able to manage getting the shells well below 300 kilos each. And then, of course, there's going to be fuel, there's going to be food, all the sort of consumables, and then there'll be the weight of the wheels, and the generators will be, I'm hoping, about 75 to 80 kilograms each, and then there'll be human beings to carry. So we're not going to end up with a sub half ton vehicle here, but I'm hoping that we could be able to come in below 1.5 or 1,800 kilos maybe. And then that would just simply be the functional unit, and then obviously you'd have to add human beings and other payload to that too. So we're going to be aiming to go significantly lighter than these other people have managed with their vehicles. And also, I want to sort of tease you with one final idea that I've had, and this is for diesel storage. We are going to carry, sorry, not diesel, HVO. I'm going to make that mistake a lot. Should we just call it biodiesel? But it's not really biodiesel, is it? No, it is HVO. Let's come up with can you come up with a better, nice name phrase for HVO? I don't like HVO as a sort of silly acronym. So please come up with an idea of what we're going to be calling Bernard's fuel source. We're going to be carrying obviously a lot of the fuel with us on board, but what if we were to lay depots? Or what if maybe one vehicle was laying fuel for another vehicle that's coming in from a different direction, which has more payload, for instance? What if we need to essentially leave fuel on the ice or maybe even in the water for a period of time before it's then picked up? I've had this idea about a way of, again, using composites and safe internal sort of fuel bladders and something like that in order to store fuel in a way that if it gets in between two lumps of ice that are trying to push against it, it won't be crushed and destroyed. What if it was like a sphere or an egg shape? Or there's a lot of testing I think I can do to try and work out a shape of a fuel storage container which can be left with a beacon on top, so you always know where it is. It will have a battery inside, so that will and a solar panel or a little wind generator or something like that, so that it pings out its location every hour, every day, whatever. And it means that you can then find it later on, but it just bobs around or just sits there on the ice safely until it's used again. So I've got this idea for storing fuel, and that's going to be another sort of sub project of the whole Bernard thing. Anyway, I think that gives you a fairly good rundown. I could have gone into loads and loads and loads of minute details about all those different subcategories, and there are a load of other much smaller subcategories I could have got onto, but that's getting towards half an hour, so it's probably enough for now. Obviously, leave me your thoughts. Tell me why you think I've made a terrible, terrible, terrible mistake. Some of you will be delighted. And I'm really hoping I'll be able to add more visuals to this soon. I'm going to do more technical drawings to try and get some 3D representations put together of what this might end up looking like, because those AI ones were a little bit but yeah, it shows potential, and it means I can be interested in that side of AI rather than doing AI voiceover Alex, which will not happen. I'm almost slightly offended when people think that I'm doing AI voiceover for some of my videos. I promise they are all me. Anyway, ideas, criticisms, joyous displays of absolute wonderment, please place in the comments. You know what to do there. If anyone wants to try and get involved in any aspect of the project, email me, DM me, or actually no, don't DM me, just email me, and we can have a chat. That would be awesome, because this is going to be quite a big project. It'd be great to have a sort of a nice community effort to try and put this whole thing together. I will put in the hours. You know that I do that. I promise you my blood, sweat and tears, and hopefully we can start making some progress. Really excited to get the scale prototype finished soon, and that will be on the snow in Iceland in February. That's all booked and ready to go, and I will finish the video off of making that shell as soon as I possibly can. I think that's probably it for now. Not done with you yet, people of the channel. I can't let you escape without more evidence that I am tirelessly exploring the minutiae of how various recipes of carbon fibre composite laminations behave. This time I want to see how a continuous sheet of unidirectional carbon compares to an interloper. Two pieces merely overlapped and then resined up and cured. First, the deflection test. Which is stiffer, I hear you demand to know. Stiffness is of course a key quality of carbon, so I will not disappoint you. Despite the overlap zone on the rearmost one adding some thickness, it's a win for the continuous piece. This means it may not be a great idea to build Bernard from a patchwork of hundreds of offcuts of composite fabric. Then, as is my way, we move to the wanton destructive phase. Let's snap the single continuous sheet of 1 ply of unicarbon in half. Impressive ability to curl into a tight radius as ever, without any telltale audible complaints from either carbon or the epoxy, but that won't last forever. I always win these battles. We get a rather predictable second or two of cracking sounds as some fibres give up, and then an instant catastrophic failure of the whole sheet. As you can see from the unidirectional layup, 100% of the mechanical strength is in one plane, so you can fold, snap and separate the parallel fibres with ease in the 90-degree direction. That's our benchmark. I'm actually interested not so much in the comparative force needed to break the overlapped one, and besides, my arms and wrists do not contain a calibrated tensile strength meter. Instead, I want to know where the fracture occurs. Let's see. Or rather, let's see once that mischievously sprung-loaded sheet tries to attack me before I manage to attack it. This one breaks too, of course, but you can see that flatter, thick zone where there are 2 plies of carbon overlapping over each other, bonded with the resin. The fracture is clean and across the whole width as before, but I will now reward your impatience and show you what happened. Back to my genre-leading graphics work. The first one, the single ply at the bottom, snapped, so we'll get that one out of the way. There are all sorts of potential modes of failure for the overlapped one. The 2 parts could split at the resin interface and delaminate, or it could break at a thinner part, a single ply, or at the edge of the overlap zone, or the thickest part in the middle, or the other edge, or on the other single ply. Now for the result. It fractured on the edge of the double-plied overlap. This is food for thought. It's possible the sudden change from one thickness to another provided a focus for the forces involved to concentrate. When making a proper shell, we therefore need to make sure that the inevitable fabric sheath edges don't all meet at the same area to spread the risk. So cheers from my hotel room in the most flamboyant part of northern England, Yorkshire. Bye.